It's 542. Okay, it's gone.
Okay, guys, today we're going to learn about logarithms and properties of logarithms, and you kind of learned in the earlier lesson how to go from exponential form to logarithmic form and logarithmic to exponential, and you got a little bit of a feel for it, but we haven't really worked any practical problems yet. You just kind of switch back and forth. So what we're going to do today is learn some practical problems. All right, now we're going to find out one of the really important properties of logarithms. What if I ask you to evaluate, I wanted you to evaluate log base 7 of 7 raised to the 3. How would I do that? I would set it equal to, somebody said it, y, okay, is equal to log 7 of 7 to the 3, okay, and then what do I do? 7 to the 3 is equal to 7 to the y, okay, and therefore y is equal to what? 3. Do you see how that works? Let's do another one. So if I have log 2 of 2 to the 20, what do I do? Y is equal to log 2 of 2 to the 20, right? And so what do I do to get rid of the log? 2 to the 20 is equal to 2 to the y, and so y is equal to what? 20. So one of the things that we see is one of the properties of a logarithm. If I have log base a of a to the b, what is that equal to? B. If the number here in the base match, then everything just drops out and becomes b. Does that make sense? This is one of the properties that you have to memorize. Because a lot of times you'll have a really hard problem and you'll see that A matches A, and then what can you do? It just goes away. Or let's think of another one. What if I had log 2 of 8 squared? How would I do that? What do I wish this 8 was? How could I rewrite that?
2 cubed.
Log 2 of 2 cubed, then what?
Squared.
Squared? Okay. And then that would be log 2 of 2 to the 3 to the 2 is going to be what?
6.
Okay. And so that's going to be equal to 6. You see how you can simplify things if you know this rule? There is another rule. Okay, so let's think about this. If you think about that, what if I have log a of a to the 1? That's going to be equal to what? 1. And so what you have to see is you don't usually write that a. And so what you have to see is if I have log a of a, that's always going to be equal to what? 1. All right? And if I have log b of, if I have log a of a to the b, that's just going to be equal to b. So those are two good rules, right? Now this is one that's really, 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 really important. And this is one that's going to be on the ACT. And so if you know this, it makes a lot of the ACT problems really easy. If I have log base b of, let's say, m times n. If I have log base b of m times m, this is really cool what happens. It becomes log b of m plus log b of n. So log of something times something times something becomes log of the first term plus log of the second term plus log of the third term. Does that make sense? Okay. Go ahead. What were you going to ask?
No, I figured it out.
Okay. So let's write that down. Let's say log a of x times y is going to be equal to what? Levi, what's it equal to? Log
A
a
of X
of x
plus log A of Y.
plus log a of y. And that allows us to solve problems that sometimes otherwise we couldn't solve. So let's see if we could break this up. If you had log 3 of 28, what's another way that I could write that? That's log 3 of what times what? 7 times 4, which would be log 3 of, and then what? Plus log 3 of 4. All right, that's pretty important. Okay, and this is why it's important. Let me show you something. What if I told you, I'm going to tell you something. I tell you, what am I going to tell you? That log 2 of 3 is equal to 1.585. I'm going to tell you that, right? That's free information. But then I'm going to ask you, what is log 2 of 48? Okay? Now that's kind of interesting. I want to know log 2 of 48.
Split it up so that one part of 48 is 3.
Yeah, okay. So what you want to do is, you want to say this is log 2, and you want to say something times what? Times 3, right? And then we'll end up with a term that we can do something with. So it would be 3 times what? 16, did you say? Okay, 16. Okay. Now, Josie, you agree with that? Now I could say, what could I do now, Josie? What could I do with this term?
Log 2 of 16 plus log 2 of 3.
Okay, tell me why you're happy, Josie.
Because it's
This one is what? Right? Now, am I all the way done yet? No. But am I well on my way? Okay, Mario, we got to deal with this term. So tell me something I could do with this term. Okay. Levi, you said what? Log 2 of what?
2
That's not 2 cubed. To the 4th. Okay. Plus, and now I'm going to go ahead and put the number in 1.585. Okay. Now, Jaden, what is log 2 of 2 to the 4th?
2 to the 4th.
It's 2? The B is what? Okay, you got it? This is like really new stuff, so it takes a while to get okay. So log 2 of 2, the A is 2, and the B is 4, so it's 4 plus 1.585, which is equal to 5.585. 5.585. Does that make sense? Okay. I'm going to tell you that log base 4 of 2 is equal to 0.5. and I want to ask you what log base 4 of 32 is equal to. Okay? Braden, tell me what you might try there.
Divide 32 by 2, so you get a number times 2. So you do that one trick.
Okay, so you want me to put log 4 of what?
Of 16 times 2.
16 times 2. Okay. Now what do you do?
Log 4 of 16 plus log 4 of 2.
Log 4 of 16 plus log 4 of 2. What makes you smile, Braden?
That's correct.
Well, but what yeah, what progress did
That's
you make?
0.5 right?
Yeah, so you know this one, right? So because this one, you got it in terms of that, so now this just becomes 0.5 plus, now I still have to deal with this one. So Logan, what would you do with log 4 of 16?
Log 4 of 16 would become, would become log 4 of 4 squared.
Of 4 squared, okay. And now, what does this become?
That is now
2, because of that rule. So that's 2 plus 0.5 is equal to 2.5. Does that make sense? Okay, everybody see that? All right, I'm gonna, there's another way that you could have done this one, I think. Let's see, no, maybe not. That was really the best way. That was the best way to do it. Okay. Okay, thank you. It's just when I hear that, it makes me think something's going on. Okay, thank you. All right. So what if I have log b of m over n? You guys just guess and tell me, what would you think log b of m over n is if you were just going to guess?
Log b of m minus.
log B of
Yes.
n.
Log b of m minus log b of n. Okay? And so it's kind of like this rule, only if you're dividing, let's say log a of x over y, it becomes a minus. So that's like equal to log a of x minus log a of y. All right? And you could sort of see this, like, you can see where we got it. Your intuition told you. But how could I rewrite m over n? I could write it as m times what?
1 over n.
1 over n, and 1 over n is n raised to the what? Negative 1. Okay? And so that would be log b of m plus log b, that's log b of n minus 1, and then the minus 1 would come down, right? And then it would be minus, okay? See, it's a different way of doing it. So, you got to remember these 4 rules. In most logarithm problems, you can work with those 4 rules. Now, this is a big one, okay? And the rule is log b of m raised to the p, log b of m raised to the p, you can bring the p down, and it becomes p times log b of m. P times log b of m. So you see, if you have a power here, you can bring the power down. So let's say that I have log 2 of 32. How could I rewrite log 2 of 32?
1
What?
1 and parentheses.
You got to deal with this. It's log 2 of what? Of 2 to the 5th, right? Does that make sense? And then what can I do with the 5? I can bring it down. So that's 5. You know, I can bring it down based on this rule, which is log a of x to the y is equal to y log a of x. So I can bring the 5 down, right? Log 2 of 2. Now, Josie, what's log 2 of 2? It's 1. So the answer is just 5. Does that make sense? Now I'm going to show you a trick. And don't fall for this because it's a trick problem. So what if I have log 4 of x squared? What is that equal to? I can rewrite that as what?
Log 4 of x plus log 4 of x.
Okay, or if you use this rule, you can just simply say what? 2 times log 4 of x. And Braden, what you said is log 4 of x plus log 4 of x. That's right. You're right. But then log 4 of x plus log 4 of x becomes what?
2 log 4 x.
So you got to the right answer a different way. All right, you used a different rule and you got to the right answer a different way. Now this is the trick though that they're going to try to pull on you. What is log 4 of 9x squared? What's log 4 of 9x squared? Yes.
2 times log 4 9x.
No. I'm glad you said that because that's the mistake everyone makes. Why can I not bring the 2 down?
Because the 9 isn't squared.
Because the 9 isn't squared. Right? The 9 isn't squared. So tell me one way that we could deal with this. What's one way that we could deal with it?
It'd be 2 times log 4 of 3x.
Okay, tell me what the step is that you're going to do.
So you change 9 to 3 squared.
Yeah, so he's going to change log 4, and he's going to say it's now 3x whole thing squared. And now, because it's the whole thing squared, what can I do with the 2? 2 log 4 of 3x. You can only bring the exponent down if what? The whole thing is squared. Okay, so Braden was thinking, and Braden, you think all the way to the end, which is good, but the reason I back up is so everyone sees how you got to it. So it becomes 9x squared is 3x whole thing squared, then the 2 will come down. Okay, Logan, I want you to tell me, that was right. Tell me another way that you could deal with this, right? Instead of making this 3x squared, what's another way that you could deal with this?
Could you do so you could do 4. But could you do that because it's the 9's not squared?
This doesn't have anything to do with being squared.
Okay.
Okay, it's just something times something. What's it going to be?
9
Log 4 of?
4 of 9 plus log 4 of x squared.
Now what can you do? Plus what?
2
2
log 4x.
log 4 of x. Okay, but what you have to see is the one thing that you cannot do is you cannot bring the 2 down here. But I showed you 2 different ways that you could break the problem down. 2 different ways that you can break the problem down. Okay? All right, let's look at let's try to work this. Log 4 of 16. How can you rewrite that?
16 equals 4 to the right.
Yeah, but I want you to do it this new way. Okay, you're going back and changing it to exponential form, which is not wrong. But I want you to apply one of these rules. What could you change 16 to?
4 squared.
Yes. Levi, what can I do now?
It's equal to 2.
No, tell me what to do though.
log of A equals
I can bring the two what?
out.
Yeah, so I get what?
2 times log 4.
Which is 1, so it's 2.
Okay. But Levi, make sure you're putting your steps in and don't jump to an answer because these are simple ones, but you got to put your steps in so when you get to harder ones, you'll know how to do it. Okay? So let's say that I have log 4 of 6 is equal to 1.29. Now I'm going to tell you that. But I want to know what is log 4 of 36. Okay, Josie, tell me something that you would do here.
I would log 4 6 squared.
Of 6 squared. Okay. Josie, now tell me what you could do.
I would log 2.
Okay, so it's 2 log 4 of 6. Now, Josie, what would you do?
I would put down 2 times 1.29.
Yeah, because you know that one. 2 times 1.29 is equal to 2.585. Does that make sense? Okay, now I'm going to show you one that you got to be really careful. Because you know how I talk about the square root of a squared plus b squared is not a plus b, right? That's the most common mistake that we make. A plus b squared is not a squared plus b squared. Remember that? This is the other #1 mistake that high school students make in math. Okay, let's say that I have 3 log 5 of x minus log 5 of 4 is equal to log 5 of 16. Tell me what I cannot do. I can't just drop off the logs. Okay, I just cannot just drop off the logs. So look at that and tell me something that I could do, or just talk out loud a little bit. Levi, if you look at that, like what rule might you be able to apply?
The right side have log 5 squared.
You could do that, okay, but it's not really gaining you anything at this point. Yes, Mario?
You could put the 3 back into the x.
Yeah, I need to get this 3 up here so I could have log 5 of x what? Cubed minus log 5 of 4 is equal to log 5 of 16. All right, Josie, tell me something that I could do now.
Now can you,
Talk out loud.
because it's not 3 log 5 anymore, now can you drop off?
No, because I got this and this and this. You can only drop the logs if it's log of something equals log of something. That's the only time you can drop it off. Mario.
You have x cubed, but for log 5 of x cubed.
Yeah, I can take this into this, right? I can make it one term. Log 5 of what?
X cubed over
X cubed over 4 is equal to what? Now, Jaden, what can I do? Now I've got log of something equals log of something.
log of 5.
No, you can
Oh, you can drop it.
you can drop them now because you have just log of something and log of something. Then you can drop it. So then you have x cubed over 4 is equal to 16. So x cubed is equal to what?
16 times 4.
64, right? and x is equal to 4, because 4 times 4 times 4 is 64. All right? I wish they would get rid of that lawnmower. Is that annoying anyone else?
Yes.
It's really annoying. You know how like little sounds bother me? Yeah. That lawnmower is really, really bothering me. Okay, so let's work another one. Log 4 of x plus log 4 of x minus 6 is equal to 2. Okay? So Josie, tell me what you would do here. Tell me what you would do.
Right. Log 4 x times x minus 6.
X minus 6 is equal to what? 2. All right, well there's nothing that I can do with this change of base here, so to get rid of this log, I need to what?
Do you need to have a log for other side?
It'd be nice, but I can't get that. So I need, remember how we could go from logarithmic form to,
Exponential.
so how would I do that? This would then be what?
X.
X times x minus 6 is equal to what? 4 squared. So now, Jaden, what do? I got to solve for x. What would you suggest? Okay, so I'm going to have x squared minus 6x is equal to 16. Jaden, what would you do now?
Subtract 6x from both sides.
Subtract.
Add 6x to both sides.
Okay, what you have to see is when there's a squared here, what should you be screaming? This is a what? Because there's a squared there. A quadratic. So on quadratics, do we put some of the x's on one side and some of the x's on the other?
6 squared minus 6x minus 6.
Yeah. You see, you're trying to isolate x, but you can't isolate x because it's a what? So you got to put it in a quadratic form. So I have x squared minus 6x minus 16 equals 0. And now I do what? I what? Factor. Okay. Braden, you want to take a shot at it?
X minus 8, x plus 2.
Yeah, you're a factoring machine, man. Okay, now what do I do now? Josie, I do what? I write down what to get to a solution?
X minus 8 equals 0.
X minus 8 equals 0. X is equal to 8. And then x plus 2 equals 0. X is equal to negative 2. Okay? I have two solutions. All right, I have two solutions. All right, I am going to be gone tomorrow, so I'm going to give you 2 days worth of homework. And so this is Chapter 9, Section 3, and then Chapter 9, Section 3, and this is going to be due Tuesday, and this is going to be due Wednesday. And I need to look at my book so that I give you a lot of good homework. What?
Do we turn it in on Tuesday or we just turn it all in?
You can turn them all in on Wednesday, but have it ready for tomorrow. And it's done on how many homework sheets? 2. Do not combine them onto one homework.